Hello friends, welcome to our channel. In today's video we will talk about what is rectifier and how its work. What is rectifier? Rectification is the process of converting alternating current, AC, to direct current, DC. This process is important in many electronic devices because most devices require DC to operate properly. Rectification is used in a wide range of applications, including power supplies, battery charging, motor control, and lighting. Rectifier basic work principle. The basic principle of rectification is to allow current to flow in only one direction. This is done using a device called a rectifier, which is typically a semiconductor device like a diode. Diodes are commonly used in rectification because they allow current to flow in one direction but block it from flowing in the opposite direction. There are several different types of rectification, including half-wave rectification, full-wave rectification, and bridge rectification. Each type of rectification has its own advantages and disadvantages, depending on the specific application. Half-wave rectification is the simplest form of rectification. In this method, a single diode is used to rectify the AC signal. The diode is placed in series with the load, and the AC signal is applied across the diode and load. During the positive half cycle of the AC signal, the diode is forward biased and allows current to flow through the load. During the negative half cycle of the AC signal, the diode is reverse biased and blocks current flow. The output of the rectifier is the positive half cycle of the AC signal. Full-wave rectification is a more efficient method of rectification because it uses both the positive and negative half cycles of the AC signal. In this method, 4 diodes are used to form a bridge rectifier. The AC signal is applied across 2 diagonally opposite corners of the bridge, and the output is taken across the other 2 corners. During the positive half cycle of the AC signal, the diodes on one side of the bridge are forward biased, allowing current to flow through the load. During the negative half cycle of the AC signal, the diodes on the other side of the bridge are forward biased, allowing current to flow through the load in the opposite direction. The output of the rectifier is the full-wave rectified signal, which is a smoother DC signal than the half-wave rectified signal. Bridge rectification is a modification of the full-wave rectification circuit that uses 4 diodes in a bridge configuration. In this method, the AC signal is applied across 2 diagonally opposite corners of the bridge, and the output is taken across the other 2 corners. The advantage of the bridge rectifier is that it does not require a center-tapped transformer, which is commonly used in full-wave rectification circuits. In summary, rectification is the process of converting AC to DC, and it is achieved using a rectifier circuit that allows current to flow in only one direction. There are several different types of rectification, including half-wave rectification, full-wave rectification, and bridge rectification, each with its own advantages and disadvantages. Rectification is a critical process in many electronic devices and applications, and it allows for the efficient use of power and the proper functioning of many electronic circuits.